All right. Good afternoon, everyone, or good morning, depending on where you are. My name is Justin Essery. This is the International Methods Colloquium. The IMC is a periodic, online, interactive seminar discussion on the application of quantitative statistical methodology to the social sciences, sponsored by Wake Forest University and also sponsored by Springer Publishing. Today's speaker is Dan Hopkins from the University of Pennsylvania, giving a talk about joint work with Kirk Bansack, Jens Heimmuller, and Teppei Yamamoto, all of their various universities. The talk's entitled Using Conjoint Experiments to Analyze Elections, the Essential Role of the Average Marginal Component Effect, or AMCE. Dan's talk is going to last between 30 to 40 minutes, after which point we will take questions from the audience. You can ask a question using the Zoom Q&A button that appears at the bottom of your webinar window. And you can ask questions at any time during the talk, but all questions will be held until the end of the presentation. If you wish to be recognized and ask your question via audio, please indicate this in the Q&A text box. Otherwise, I will read your question during the Q&A period. And welcome to my co-host, Bullet the Cat. A link to Dan's paper and slides will be available in the Zoom webinar chat window so that you may refer to it throughout the presentation. And now I'd like to welcome Dan Hopkins to the IMC. Dan, welcome.
Great. Justin, thank you so much for having me. As Justin mentioned, the title of this talk is Using Conjoint Experiments to Analyze Elections, the Essential Role of the Average Marginal Component Effect. And this is joint work, exactly as Justin mentioned, with Kirk Bansack, Jens Heimmuller, and Teppei Yamamoto. So I want to start actually just by thanking Justin. This is a really neat endeavor. As in the last several years, the leadership of the Political Methodology Society has worked really hard to diversify the set of people who are able to engage with the section, and worked really hard to democratize the section, to make its content more available. And I think that really nothing does that better than the International Methods Colloquium. So I just wanted to say a big thanks to Justin, both for the invitation and for his tireless work in creating this forum where we can talk internationally without the usual barriers that you might find with conferences. So what I'm going to be talking about today is conjoint survey experiments. Conjoint analysis is an experimental technique that was introduced in the 1970s, initially in marketing, to analyze preferences and choices about multidimensional objects. Originally, when conjoints were administered, they were often administered with pencil and paper, and the underlying math relied on orthogonal matrices because the designer of a conjoint wanted to know what is the smallest set of profiles that I can give and still generate unique results. That said, if you meet people who did conjoint surveys in the pre-computer era, they often would fill out 72 different forms evaluating a whole set of possible combinations of attributes, right? So in that world, the shift to computer-assisted survey administration has been revolutionary because it's enabled us to move from orthogonal matrices to design our conjoints to a fully randomized design, which has provided a lot of power and has also meant that we can administer conjoints in a low-cost way on a broad range of topics. In recent years, they've seen extensive use in political science, and there's been some development of corresponding statistical tools, but we would argue we still have a way to go in terms of developing the full set of tools that we might need to make full use of this really, really rich survey method. One of the reasons that conjoint designs, along with the rapid growth of computer-assisted technology and surveys administered online, one of the reasons that conjoints have seen this explosion in interest and use is because they're really well matched to substantive problems that we as political scientists face. They're well matched to problems where people are asked to rate or rank multidimensional objects. And of course, we do that when we choose between two candidates or multiple candidates in a voting setting, or when we choose between parties, when we choose between immigrants as to who might be admitted to a country, when we choose between bundles of policies, when we discriminate against people, we may choose people to employ or not to employ. So conjoints have taken off both for technological reasons and for substantive reasons, because they're well matched to a lot of questions that we as political scientists have. In recent work, the most common causal estimand has been the average marginal component effect, which is something that Jens Tepe and I had introduced in a 2014 political analysis paper. And this talk today is going to focus on the AMCE because it's gotten a lot of attention from people who think that it has utility and from people who question that utility. I think it's fair to say that the statistical and empirical development of conjoint has outstripped theoretical attention to what conjoints can and cannot recover. And this talk is understandably in dialogue with a lot of that work, most notably the Abramson et al. Paper, but also the recent Ganter political analysis paper, as well as the Leeper et al. Political analysis paper from a year or two ago. One of the core points that we want to make is that we need to evaluate the AMCE based on what it was designed to do. Right? The AMCE, like any estimand, is going to be useful in some settings and not useful in other settings. And so what I want to do now is outline the relatively broad set of settings in which this is going to be a useful tool. But I think one of the core points that I want to make is that some of the disagreements, say, between our paper and the Abramson et al. Paper are as much epistemological as they are statistical or methodological. And part of what we're trying to do is to focus attention on the virtues of the AMCE and what it can do, the situations in which it can recover quantities that are meaningful and of interest to political scientists. So one such question that comes up very, very frequently is in the electoral context, right? An obvious multidimensional choice that political science is obsessed with, and understandably so, is the choice between candidates and parties. So if you were a Democratic primary voter in 2020, for instance, you had a wide range of choices you can see on the right, from Joe Biden, who ultimately won, Michael Bloomberg, Pete Buttigieg, Kamala Harris, Amy Klobuchar, et cetera. And these candidates bring distinctive bundles of attributes, right? We can think of candidates as bundling a set of, as being combinations, multidimensional combinations of attributes. Many researchers in political science have questions that take the form, what is the effect of a given attribute? So for example, what would be the impact of a given attribute on a candidate's likely vote share? And here are a couple citations, but this is, as I mentioned, been in exploding literature. There are lots and lots of substantive examples. So we looked at, we've done a couple literature reviews as part of this project. One of the things that we saw is that of all conjoint applications that we could find in political science, 27% of them were voting, where the respondents were asked to vote, to engage in some sort of simulated vote choice. So it seems important to then understand the AMCE and its interpretation in a voting setup. So that raises the question, well, what statements can we make from the AMCE? What statements can we not make from the AMCE? And this presentation is going to follow the usual outline, right? I almost don't need to put it, but it's actually not the outline of a political science talk so much as the outline of a romantic comedy, right? So what happens in a romantic comedy? Well, at first, the couple is, either meeting or falling in love and, becoming infatuated with each other. But in any good romantic comedy, there's always going to be some barrier, something that comes between them, something that causes tension before it is ultimately successfully resolved. And I want to argue that that's not a bad metaphor for conjoint. As with any method that we have seen introduced, right, whether it was matching or latent Dirichlet allocation or structural equation models, we have seen an initial excitement about the method and then some often legitimate pushback as to when the method can be effectively applied and when maybe it's getting pushed past its boundaries. And ultimately, these tools, to greater or lesser extents, all remain in our toolkits. And I think that is the broad theme of what I'm going to say today. Take-home points. The AMCE has key properties, right? It captures multidimensional trade-offs. So when are we going to reach for the AMCE? In a context in which we want to understand how voters or other individuals are making trade-offs across different kinds of attributes when they're evaluating multidimensional objects. It's also empirically tractable with credible assumptions. And this is important, right? We, particularly in an age when lots and lots of our estimators require strong assumptions and maybe functional form assumptions that may or may not be met. and may or may not be testable. And what's important too about the AMCE is it maps onto an empirical, a really meaningful empirical phenomenon of interest. So this is something that you could report to the Republican National Committee and or any practitioners, left, right, center, and they would understand the substantive meaning of it. In an electoral context, the AMCE has a straightforward interpretation as an effect on vote share, as we will see, and is one of the core points of this paper. So changing the candidate's stance, just as just an example, from backing Medicare for all to opposing it, increases or decreases their vote share by delta percentage points. That is the kind of statement that you are justified in making from the AMCE. And as far as I'm aware, I don't think there's any contestation of the legitimacy of that statement. The questions are, how useful is this estimator, and do we want to make that statement, or are there other statements that we would prefer to make? Okay. We also did a literature review of non-conjoint electoral studies to try to see, well, what are the quantities of interest there? And it turns out that vote shares, that is the very quantity that the AMCE recovers, are the most common quantity of interest in recent non-conjoint electoral studies. So it's not that the AMCE is some niche estimator that can only return a quantity that is of interest in very limited situations. It's not the case at all. Okay. I'm also going to argue that empirical results, empirical evidence, can be informative with respect to theoretical concerns. In part, the debate over the AMCE and the debate over the utility of conjoints has been a debate about the structure of people's preferences, but we can learn, say, about the heterogeneity of AMCEs. We can start to understand just how binding those theoretical concerns are in practice. Okay. So again, I think in some ways it's helpful to understand recent debates as being more epistemological than statistical. A conjoint design can often look something like this, right? Where you have a set of attributes and you have candidate A and candidate B who are defined as a bundle of draws from the distributions of each attribute. Okay, so we can see here, for instance, that somebody is asked to choose between two candidates, one of whom graduated from high school. Their largest campaign contributor is the auto worker unions. They're from Alabama and they're Republican, and so on. Right? This is the classic setup of a conjoint. Okay, and it's going to be helpful to understand this representation of the kind of data that you might see from a conjoint in an idealized scheme. So here what we have on the left side is, imagine a case where we have candidates who are valued on three attributes, A, B, and C, each of which is binary and is valued either at 0 or 1. In that context, we have 2 to the third, which is 8 possible profile values, possible profiles. And all of those profiles are given on the left side of this table, right? So we can see the profiles 1 through 8. And on the right, we have 3 types of voters and how those voters would rank those profiles, right? So we can see there's a type 1 voter. Type 1 voter likes profile 1 best of all, right? They like it when A, B, and C are all set to 1. But we would have to then look down to see, well, what's their second best? If they can't have A, B, and C all set to 1, they prefer then A and B to be set to 1 and C to be set to 0, right? We can see, however, that it's, say, a type 2 candidate, a type 2 voter prefers profile 5, and a type 3 voter prefers profile 6. Okay, so what this does is it shows the preference ranking for 3 types of voters over the profiles for candidates defined by 3 binary attributes. This is going to be useful, and I'm going to return to this before too long. Okay. So what is the AMCE? The AMCE, expressed in potential outcomes notation, right, is we're going to let y sub I be a function of 2 profiles, right? So this is in a in a context with 2 profiles where the outcome is going to be 0 or 1. You're going to choose a profile or you're going to choose the alternative, right? Depending on which profiles A, B, and C that you see. And the AMCE is then an average over both all of the voters that we ask and all of the attributes. And specifically, what we're comparing is a case where in one of the two profiles, attribute A is set to 1, versus a case where in that one profile, that attribute is set to another value. Okay. So the AMCE for attribute A is the expected difference between the potential outcomes for paired contests where attribute A for the first candidate equals 1, and the potential outcome for the contests where A equals 0, given a pre-specified distribution of the other attributes. And that is important, as work by Agami et al. has recently shown. Okay, so what do we need to say about the AMC, right? One thing when we're generating these AMCs, we only need to define preferences with respect to whole profiles, right? Not individual attributes. What's nice about the AMC is it provides a one-number summary, and there is double averaging, as in the Ganter paper. So we're averaging across the candidate profiles, and we're averaging across the voters simultaneously. Okay. Now, when we want to estimate this AMCE, causal identification comes from the design and the randomization. If you randomize these attributes to their different levels without any parametric assumptions, right? So we can use OLS to estimate the AMC, but we're just using it as an estimator. We don't need to make any normality or other kinds of parametric assumptions. So this is empirically tractable and can be straightforwardly estimated. An important point, which is sometimes missed, is that AMCEs compare changes in attributes for the same profile, not the difference in attributes across profiles. So I am not comparing a Democratic candidate to, or let's say a female candidate to a male candidate. I am comparing a male candidate with a set of attributes to a female candidate with a set of attributes relative to their competition, right? Well, what does that mean? So it's not the difference between a candidate with A being equal to 1 versus a candidate with A equals to 0, right? What we're doing is we're changing one of the two candidates in a binary forced choice example. We're changing one of the two candidates' attribute values from one level to another, okay? So this means that there could well be ties if we have a uniform randomization, right? So some of the time, a female candidate is going to face off against a female candidate. And the AMCE is going to change the first candidate's gender, but is then going to be averaging over the distribution of genders for competitors, right? And that means that the AMC has an upper bound given by the number of attribute levels, right? If I only have 2 attribute levels, then you're going to see a quarter of the time a female candidate faced off against a female candidate. And that's going to limit what the AMCE can be, because when 2 female candidates face off, one will win and one will lose. So that example, I think, reinforces the fact that, and this is the De La Cuesta paper is really helpful here, that the underlying attribute distribution is absolutely critical, right? Everything that we're saying about the AMC relies on the idea that we can generate an attribute distribution and indeed an experiment that effectively simulates the real world situation that we want to estimate, okay? But that said, we can constrain the randomization distribution. So for instance, you could constrain the randomization distribution so that female candidates only face male candidates. And that would obviously, by changing the distribution that we're averaging over, change the AMCE. Okay, so now let's return to this example. You remember this example. We have 3 attributes. So each profile can be defined as the values on these 3 attributes. And we have 3 types of voters. Okay, so now what we can do is we can calculate the average rank that each voter gives to profiles that have each attribute, right? So we can see, for instance, that the type 1 voter ranks the 4 profiles that have A equal to 1 1, 2, 3, and 4. The average of 1, 2, 3, and 4 is 2.5, right? Whereas that same type 1 voter ranks the A equal to 0 profiles, which are 5, 6, 7, and 8, to be the average of those 4 ranks, which is 6.5, right? And so what we can see then an AMCE is going to be proportional to the difference in average ranks when we switch an attribute value, okay? And that is given a uniform independent attribute distribution. If you're interested in other attribute distributions, we generalize that in the paper, okay? So what does this mean about the AMCE, right? The AMCE is proportional to the difference in average ranks, averaging over our attributes and our voters, right? So that means that the AMCE incorporates preference intensity. So, and we would argue, and this is, I think, at the end of the day, this is the core crux of the disagreement between the Abramson et al. Paper and our paper. The AMCE incorporates preference intensity. So if you have a setup where a majority of voters have, say, a slight preference for a certain attribute value, but they don't really care about that attribute value, and you have a minority of voters who, say, are one-issue voters, they will only vote on the issue of abortion, right? You can have an AMCE that is different than the majority preference, and that is, and I would take a look at Abramson et al.'s paper. That is the core point. But we would argue that this preference intensity is, for at least a wide class of political problems, a feature and not a bug. Okay, so in this, the critiques of the AMCE are parallel to a set of critiques of the average treatment effect. So imagine that you're evaluating the efficacy of a vaccine, right? And that the vaccine prevents death in a very small number of people, and it induces mild symptoms in a much larger number of people, right? We might be interested both in what is the experience of the majority of people, which might actually, on average, if we think about like healthy days, might be very slightly negative because you had that day of kind of the febrile day recovering from the vaccine. But if you have a mean-based estimator, it's obviously going to take into account the fact that if you save a small number of lives, that's going to have a huge impact. And I think that's not a bad way to understand this too, right? So the AMCE incorporates preference intensity. So it's not a statement about majority preference. And in that respect, Abramson and co-authors are entirely correct. So in the paper, we show this proposition, which is assuming that a conjoint can be reweighted to mimic the target election in terms of attributes and respondents, the AMCE will match the difference in vote share. So people say, how do you interpret an AMCE? The AMCE is the expected difference in vote share corresponding to a change in an attribute value. Okay, that's what it is. Now, there are alternate estimands that we may be interested in. Okay, and one that may seem initially appealing is the fraction of people who prefer a given attribute. And this is different. This is not what the AMCE recovers. So consider the following example. About 90% of the world is right-handed. Imagine that all else equal, if all you told me about a presidential candidate is that she or he is right-handed or left-handed. Well, I don't have much to go on, so I'm going to go with somebody who's right-handed like I am. Then, what we would see is that the fraction of people who prefer a right-handed candidate is going to be massive, right? But at the same time, the question of whether of the weight that people put on that attribute, it is going to be essentially meaningless, right? So if everybody prefers a candidate who shares their handedness, yes, we could see that 90% of the world, there's a very, very strong preference for right-handed candidates. But from a substantive and political point of view, that would be wildly misleading, right? So we would argue that in many core contexts, and most notably in the vote share context, what candidates often want to know is, what is the expected change in vote share corresponding to passage of legislation, the taking of this position, running a candidate with these attributes? And that's a question the AMCE can recover, okay? I also want to just dwell for a moment on the fact that if we are worried about the distinction between the direction of preferences and the intensity of preferences, it's worth noting that our data are often informative on that point. It's not that we necessarily have to give up on the AMCs so much as we can estimate AMCs for subgroups whom we might expect to have heterogeneous levels of intensity or preferences, right? And so my more general point here is that the data that we use can itself be informative on these theoretical questions, say about direction versus intensity, okay? So as I mentioned, the Abramson et al. Concern is chiefly about the conflation of preference direction and intensity. And one thing you could do is you could then estimate subgroup effects. If you are worried about the example that a small number of single issue voters are, say, pro-life voters, you could then look, for any observed covariate, you could then run those tests, obviously subject to multiple comparison concerns. And in fact, in our 2014 paper, we laid out conditional AMC estimands for that very purpose. Okay, so here, for instance, years ago, Jens and I had published a paper asking Americans to choose between immigrants to be admitted to the United States. And one of the core things that we showed is that the results actually are surprisingly similar for those with no college or relatively low levels of educational attainment versus those with higher levels of educational attainment. So that's the kind of test then that we might do to start to probe. Now, admittedly, not exhaustively, but to start to probe these questions, right? Subsetting is a powerful tool. It's also worth noting that these concerns apply to forced choice outcomes, right? And one of the best practices in Conjoint has been to not just ask people to choose, but also to rank profiles. So here you can see, for instance, that we, in that paper on immigration, not only ask people to choose between the two immigrants, but to rate each of them on an absolute scale. And that's going to give us yet more data. So this is to the point that these very, very valuable theoretical concerns can be addressed to some degree through data collection practices. And I would certainly recommend the collection of not just forced choice, but also ratings data wherever it's applicable. Okay. And in fact, in the paper that Jens and I wrote, the conclusions substantively were highly similar when people were evaluating profile rankings. Okay, when they were just asked, rate this ranking on a scale from 1 to 7, say. Okay. I would definitely recommend the Ganter 2021 political analysis paper. And Ganter, also motivated by both concerns about what we can say about preferences, as well as the concern about ties, generates a new estimand, the average component preference. And at least in the immigration case, it's noteworthy that it yields really pretty highly similar estimates. So I certainly would say that there are multiple estimands, and they're motivated by different assumptions. And indeed, one of the things that I want to do with the waning minutes of this talk is to talk about some alternate estimands that we might be interested in. Okay. Now, to be sure, I am not saying that the AMC is going to necessarily look like these other estimands, but when there is a divergence, that's a really, really useful diagnostic. Okay. Kirk and Jens and Tepe and I also have done a fair amount of empirical work. And one of the things that we've shown in this PSRM article from a couple years ago is in this context, the relative stability of AMCEs in the presence of a variety of other kind of filler attributes. And so that is another way in which we can gain empirical leverage through our research design on these theoretical questions. Okay. I'd also say that the AMCEs specifically and conjoints more generally have to date, and I think this is an area where there's a tremendous opportunity for additional research, but two of the assessments that I know of have found significant external validity. That is to say, both the Auerbach and Thatchell and the Hangartner et al. Evaluations, where we have both conjoint data and other forms of data about these selection processes, have indicated that the AMCEs do, in fact, at least with certain configurations of conjoint, as And here, what I'm showing are the results from that Hangartner et al. Paper, where on the far left, what we see is a behavioral benchmark. It used to be the case that select Swiss cantons would vote on individual applicants for citizenship. And so we can see behaviorally what kinds of estimates were recovered. And then we can see under what conditions, what kinds of conjoint designs could the AMCE recover similar conclusions, right? And you can see, for example, that that certain configurations of conjoint, particularly often the forced choices, do well at recovering some of our key behavioral benchmarks. Okay, so the AMCE recovers vote share differences associated with presence or absence of an attribute in a profile. Is this something political scientists care about? And in brief, the answer is yes. We did a lit review of 4 journals that focused on voting behavior between 2015 and 2019. And we found 82 non-conjoint articles. So here we're not trying to stack the deck. So we are going to focus on articles that aren't using conjoint and seeing, okay, what are the outcomes of interest? What are they estimating? And 87% either estimate aggregate vote share effects or their individual level analogs, suggesting that the problem that the AMCE solves is a problem that we as a field face on a regular basis. Okay, so AMCEs recover a meaningful quantity of interest for election researchers, which is vote shares. They recover a quantity of interest that is the quantity of interest in a significant majority of applied electoral research. And that seems to be significantly to their credit. That said, as I've been indicating, there are other quantities that we may well want to estimate. And one of the goals of our paper is to start to sketch out what those quantities look like and what are the advantages and disadvantages of them. So we may ask, for example, how likely is a specific profile to win a majority? And you can see here what that estimator looks like. One of the key points here is that we are averaging first over voters, right? Then we are identifying, using an indicator function, voters for whom the preferred profile, this selected profile, is chosen over all the alternatives, right? Then we're averaging over the attributes. Okay, and there are a variety of different versions of this. So here, for instance, we're looking at a very specific profile, ABC, comparing it to all of its alternatives. But we might also ask, how likely is a candidate with just attribute A set to little a, set to the value little a, likely to win a majority? Right? Obviously, in voting context, majority questions are questions about who would win a majority are important ones. Okay. Or as a related version of this, we might ask, how likely is a candidate who has A equal to little a to beat candidate A equals A prime? Okay. And our paper, as I mentioned, sketches some possible estimation strategies, and there is also some other work you'd consult. One thing that I want to make clear here is that these quantities do seem like you can feasibly estimate them, and they are distinctive in that from another quantity. So this, at first glance, looks somewhat similar. So this is the fraction of people preferring a certain attribute, so preferring A to A prime. But you'll notice here that we are first needing to take the expectation with respect to all of the attributes. And only then later do we get to, so we have to figure out for each individual across all attributes, do they prefer this attribute value? And then we need to average that over the population. So this is a much harder estimation problem because for a given individual, there are tremendous sparsity issues, right? If you think about all of the possible profile combinations and the tiny number that any individual would actually be able to evaluate. And I had mentioned at the outset of the talk that one of the advantages of administering conjoints in a fully randomized way via computer is that we can get around the problem of having individuals needing to evaluate, say, 72 profiles or a whole set of profiles. And to get at the fraction preferring using conjoint data, we're right back in that challenge of needing just a tremendous amount of data or needing to start to layer on, building in some modeling. Okay. Here, what we would have done is, classify all voters into those who prefer the female candidate and those who prefer the male candidate, then calculate the proportion of the female prefers. But because of that sparsity issue, here with respect to individuals, inference about this, at least to our initial explorations, appears intractable. Okay. But I think also we would suggest that if this is your quantity of interest, conjoint may not be the right, conjoint may not be the right design. You may want to use a different or a more straightforward experimental design. Okay, so great. So by way of concluding, one generic piece of methodological advice that I've never seen to be incorrect is you want to fit your estimand to the substantive research question. There is no all-purpose estimand that is going to work in all contexts, right? And that, I think, is true here as it was in debates about matching or other, wide range of other debates. That said, the AMCE has key value, and the dozens of papers that have been estimated via the AMCE that have used the AMCE are, tell us something and tell us something really important about the world. Specifically, if in an electoral context, they tell us about changes in vote shares associated with changes in attribute values. The AMCE captures the multidimensionality of electoral choices, right? It is empirically tractable without strong modeling assumptions. And it recovers a meaningful quantity of interest, which is the change in vote shares, that many of us care about in our applied scholarship. Okay. Not only that, the AMCE has been part of 2 external validations in which conjoints can recover non-experimental benchmarks. Okay. As always, one of the critical challenges in using conjoint is to set up the attributes in a realistic way, such that, or in a way that recovers, and again, that Della Cuesta paper is really helpful on the critical role of the attribute distribution. We are averaging over an attribute distribution, so we've got to be really thoughtful about what that attribute distribution is. Okay. I would argue that some of the critiques of the AMCE in recent years are for things that it wasn't designed to do, or clearly not its strengths. And I think that's, I think we would frankly acknowledge that, right? That, like, just as LeBron James is the greatest basketball player, but you wouldn't necessarily ask him to play badminton. I mean, I'll bet he's pretty good at badminton too, but that's not how we'd evaluate him, right? So too, we would suggest that the AMCE, there are a straightforward set of ways to evaluate it, and that it scores highly on those measures. So on that note, I really look forward to your questions, and I appreciate everybody's time and attention.
All right. Thank you, Dan, for that presentation. At this point, Dan Hopkins is available to take questions from the audience. You may ask a question using the Zoom Q&A button that appears at the bottom of your webinar window. If you wish to be recognized and ask your question via audio, please indicate this in the Q&A text box, and I'll unmute you. Otherwise, I will read your question aloud during the Q&A period. And I want to start off by asking a question that I had. So I was at the original Paul Math talk where this earlier paper was discussed, and as I understand it, the heart of the critique is essentially the heart of the critique of the AMCE is that Arrow's possibility theorem, or impossibility theorem, depending on who you ask, says that essentially there can't be a coherent preference ordering in a democratic multidimensional preference sort of system. And the AMCE, therefore, can't provide that. And so what I hear you saying is, well, what it's providing is an average, essentially vote share change or vote share effect of some attribute. Well, okay, so I was just sort of thinking of a toy example. So suppose you run a female conservative against a male liberal, and the female conservative wins 60-40. And then you run a male liberal against a female liberal, and the male liberal wins 60-40. You run a female liberal against a male conservative. The female liberal runs 60-40, or wins 60-40. You run a male conservative against a female conservative. The male conservative wins 60-40, right? So what's the average effect of being female? Well, it's zero if you sort of weight all the attributes equally. But being female does have an important effect on the vote share, right? It just depends on the context. So given that conjoint experiments sort of average over lots of different contexts, what's the advantage of doing that rather than sort of basically not averaging over tons of context, but rather focusing in on specific bundles or scenarios that are relevant to a particular election or a particular this thing I'm studying, right?
That's a great question. And I think that each approach has its merits. But I think one of the keys in thinking about the value of conjoint is to think about what we compare it to, right? So if I, what would I have done pre-conjoint? Maybe I would have set up a very specific example where we have two particular candidates and I have to pipe in a whole bunch of attribute values, but for the couple attribute values that I'm interested in, right? And what conjoint lets me do then is, rather than have to fix, so we as experimental researchers have to kind of pick a place in multidimensional space. And conjoint says, hey, a conjoint design allows me, rather than picking a very specific place and setting, so you talked about ideology and gender, so I have to set everything else. Conjoint says, hey, if I can specify an attribute distribution, then I can just learn a lot more, because I can not only learn about the average treatment effects in that one specific context, but I can then recover, say heterogeneous treatment effects, or I can look at the interactions across attributes. And I think that, so that's part of what I would say. This all relies, like the trick, the critical point is that the attribute distribution that we are averaging over has to be sensible and it has to be meaningful. But I think there too, I would point to the fact that we can always look at subgroups, right? Particularly mindful of multiple comparison issues. We can look at subgroups and we can see, are these different estimates stable in the presence of different subgroups? And it turns out, so Suzanne Schwartz and Alex Kopic have a paper where they have reanalyzed a whole bunch of conjoint estimates of gender effects, right? And you can then, I think that then part of my answer to your question is, yes, this, at the end of the day, we are not saying that, that Arrow was wrong, right? There is a obvious social choice problem. That said, to the extent that we can make our conjoints look like the electoral context that we're interested in studying, they give us a lot of data on those choices. Does that answer your question, Justin?
Well, yeah. I mean, what I'm really trying to sort of sort out for myself is, for example, if I wanted to know, actually, this is something I really study, right? What's the effect of gender on voter preferences in the presence of possible corruption, right, in the government? And just from some work I've done, it really depends on what else is going on, right? It depends on who the opponent is and their characteristics, and there's a lot of heterogeneity in how voters respond based on not just the other characteristics of the candidate herself, but also of the other candidate. And the AMCE, which is not really, because they weren't always conjoint experiments, but it's sort of what was being calculated already, averages over all those things and you sort of get nothing. But if you start to break it up, which is what you were just referring to, you start to break up these effects, you actually do see essentially countervailing. Sometimes it goes one direction, sometimes it goes the other direction, and they average to zero. So it's what I'm trying to figure out is, okay, should I what things should I average over, right? So that I'm not obscuring. I'm not creating this I'm not averaging over multiple preferences that will sort of make it look like there's nothing there, but actually there's a great deal there.
Yeah, no, and I would definitely check out the Agami and Amai paper on so one of the challenges is that you can the population of higher order interactions is huge, right? And
Right.
so we need to be principled. Both, you would want to pre-register these designs, and we want to think about ways. And then the Agami and Amai paper is really helpful on thinking about how do we sort out the limited number of kind of meaningful interactions from the lots of spuriousness. But that said, what I would say is that we would rather know that there's this heterogeneity, right? Particularly because experiments are costly. We're not able to run experiments all the time. And so, and I think that the danger is precisely because Conjoint recovers so many possible estimates, I think pre-registration becomes really important. Because thinking about multiple comparisons becomes really important because there are so many possible estimates that we could be deriving from, the data are so rich. But I do think that also that they then make these kinds of questions into empirical questions insofar as we can look at heterogeneity across a variety of, valued, both, we can look at heterogeneity across attributes, do these attributes interact? And we can look at heterogeneity across individuals by subgroup.
I wonder if it's possible to integrate some form of directed learning or machine learning while the experiment is being rolled out. Let me explain what I mean. You basically imagine you're on a pilot, and then that pilot informs how you randomize attributes in the larger sample, right? You can imagine basically early data giving you some indicator of where it's safe to average and where it's not safe to average, which would make would allow you to sort of only randomize in those on those dimensions where it's really safe to do it, right? You're just sort of averaging over additive preferences or something. Mm-hmm. And where it's not, you say, okay, we shouldn't do that. We should actually break this up.
And I think that the context in which preferences are additive or not is really, really interesting. So I think there's a ton of outstanding research to be done there.
Well, we have a lot of questions, so I would like to get to those. First, Thomas Ball asks, he's quoting, I think here, changing the candidate stance from backing Medicare for all to opposing it increases or decreases their vote share by X percentage points, unquote. Statements like these have been subject to challenge. Notably, conjoint estimates are notoriously unstable. 2, this methodology is most effective with hard attributes such as tech device options and less effective with soft or qualitative attributes such as political candidate attributes with respect to political opinions. I guess it's more of a comment than a question, but I'd like to know how you'd respond.
For sure. So Thomas, I really appreciate the question. My experience has not been that conjoint estimates are notoriously unstable. So I'd be very curious to see what are the contexts. Obviously, again, it's a question where there is not one rule that fits all, but I had showed earlier the stability of the AMCEs when we piped in a whole bunch of filler attributes. That's a test that we've used for, to get at various properties and to answer questions like, how many of these profiles can you ask people before they just satisfy a way into meaninglessness? But it is not, certainly as a researcher and as a reviewer, it has not been my experience that these estimates are sort of notoriously unstable. I'd be very curious for citations or other cases where that is shown. So the methodology is most effective with hard attributes such as tech device options and less effective with soft or qualitative attributes. So I think that to me is a definitely interesting question. I would love to see it's a really interesting question, right? Are we going to get better estimates for candidate gender? And this obviously just relates to external validity concerns. One of the areas that I would love to see Conjoint go into is moving away from just these table-based presentations to say like video-based presentations or presentations that give data in ways that are more similar to how we as voters encounter them in the world, right? We could be Facebook, or there are a variety of ways we could present this data. And it may well be that the table format that we're so used to using is not going to be universally valid. So I would totally buy that. And it may be that the table format calls attention to certain attributes that we would never search out. But I would say, with all that said, I would say that in the context that I know best, elections and immigration, conjoint estimates have actually proven relatively stable. Indeed, I've seen a number of papers say suggesting that the preferences that people express through conjoints for immigrants are stable across countries, to say nothing of subgroups. So I'd be curious, and I'd really welcome any citations you have on that have helped inform your prior.
And he says they're from the marketing literature, and he'll send them to you. So thanks for that. I have a live question from Jen Gaudette, so I'm going to unmute Jen right now. Jen, can you hear me?
Yes, can you hear me?
Yes, please go ahead.
Great, fascinating presentation. Thank you so much. I actually just ran a conjoint experiment. And so one thing I was hoping you could speak to was how you thought conjoint experiments held up across survey platforms. So I ran mine using Lucid Theorem and actually lost 1,000 respondents with the first attention check out of 3,000. Thankfully, I'm not paying for them. And then with the second attention check after the conjoint portion, only lose about 100 of the remaining. So I was just curious about quality of survey platform, how you think those affect these results.
So that's a great question. And one of the things is we tried to understand the, just like how practically do you administer these? How many profiles can you ask somebody to do before they get bored? And those, how many attributes can be included? We have done extensive work on Turk and using online Optin samples, say through, SSI, which I think is now Research One, right? Dinata, I apologize. But what I would say is a couple things. First, as compared to other kinds of surveys, conjoints seem to be a little more engaging. Now, it may be novelty value. It may be that if we all do conjoints, that novelty value goes away. But we have consistently, in open-ended questions, have gotten feedback like, oh, this was interesting, right? And so I think that does help. Our experience has been both on Turk and on the online opt-in platforms. We haven't done Lucid specifically, but I imagine this would generalize to Lucid, that those people, they pay attention, and the concern I have with them is not that they'll give meaningless answers, but it's more that they would, assuming they're not a bot, but more that they would pick one attribute and just use that one attribute, right? But one of the things we found is that you can ask people on Turk or these online opt-in respondents up to 30 profiles, and the AMCEs don't really degrade for a long time. So I don't want to say that this always you need to do those checks. But one thing that we have found in general is that you can ask people a fair number of profiles, and indeed that it pays to do so in terms of the statistical precision that you get with your standard errors. Is that responsive to your question?
Yeah, absolutely. And I actually worked with Kirk on developing mine. So cool. Thank you so much.
Cool, thank you.
There's actually a sort of related question in the Q&A. Michelle Garagnani, God, I'm sure I butchered that. Michelle asks, very insightful talk. Could you talk about how many observations you would recommend for this procedure to have enough power and how they relate to the number of attributes?
Yeah, so that's a great question. And this is it's one of the most common questions that I've seen with Conjoint, right? Which is questions around statistical power. So, one thing to keep in mind is we obviously want an attribute distribution that's going to capture the richness of the attributes that we're interested in. But the more attributes that you ask, the less power that you will have on any given one, because that one attribute is going to appear in fewer of your profiles, right? We have found that in general, once you've recruited a respondent, it is almost always valuable to ask them to do a good number of tasks, right? So as I mentioned, we found that you can ask up to 30, but that say like standard practice seems to be asking people maybe to do 5 tasks. And we think that people can very comfortably bump that number up. So we're averaging over attributes and we're averaging over individuals. So the more data we get on both, the better. But given that the costs are concentrated on recruiting this one person, I would say that in our political analysis paper and our PSRM paper have indicated that you can ask people a fair number of these tasks. So by fair number, I mean at least 10. So I don't know if I have specific guidelines. So I would say, pay attention to the number of attribute levels because power is decreasing in the number of attribute levels. And given the costs of recruitment, I would err on the side of asking people more, asking people to evaluate more tasks or more profiles.
An anonymous attendee asks if AMCE can be interpreted as the effect on vote share in multi-party electoral competition, i.e. or e.g. Multi-member district systems.
So so it depends on the voting rule, but the short answer is that if you can specify the estimand is the way that you wish to, then so if we have certainly if you had this generalizes to the vote share effect generalizes to a context where I may choose between any number of different attribute values, right? One of the nice things about the AMCE is since I am comparing the changing one candidate or one party's attribute value, it can be relative to just one other alternative or a wide range of other alternatives. But if we're then getting into more complex voting rules, I would need to think about the specific example.
We are right at the limit of our time. So if there are other questions, you may want to email Dan privately. But for today's talk, I'd like to wrap it up. Thank Dan for being our presenter today. I want to remind everyone that the presentation will be posted to our website shortly after the broadcast. If you'd like to share this presentation with a colleague or watch it again later. I also hope you will join us next week, next Friday, same time, 12 noon Eastern, where we are going to host a talk from Amber Boydston of UC Davis and Jessica Fizel of the University of New Mexico. Their talk is entitled Self-Coding, a Method to Assess Semantic Validity and Bias When Coding Open-Ended Responses. Please see our website, www.methods-colloquium.com, to get some more information about this talk. And Dan, thanks again for being here today.
Justin, thank you so much. And thanks to everybody in the audience for great questions.
Hope to see everyone next week.